want to introduce you to David Schie from Linear. He's the CEO of Linear Dimension Semiconductor. And his motto or his mission in life is to take the geek factor out of technology. So let's welcome him to the stage.
All right. Well, hello, everyone. It's great to be here today. And yeah, that's what we're about. We're trying to take the geek factor out of technology. As you know, I'm sure your wives and so forth, if you're an engineer, think we're all kind of geeks, and so it's a difficult challenge. But for the last 17 years, I've been involved in interfacing at multiple levels the sensors that are enabling these new revolutions with the devices, the power, and the form factors that are going to be the next generation of wearable devices. So we're very excited about what wearables can do for us. For the first time, devices, sensors, and electronics can interface with the human body to make things easier, more convenient, more entertaining, and do a lot of things for us. So I was tasked with the difficult challenge of bringing you a little bit up to speed on the present state of wearables, and then talking about some of the technology, some of the challenges and solutions, and then finally, I'm going to leave you with some predictions that might be a little bit far out, but you can tell me in future CESs whether it's right or wrong and give me praise or alternative. Oops. So the first point we need to make is, what do we see wearables as? I mean, what are they? So to us, wearables are the next step in the man-machine interface. We've been working for years to try to get something more convenient, something a little easier to use, something that can get more information. And it's kind of an evolution like that of man himself. We started with the old cell phones in a bag that Motorola used to sell. And then we had the great big phone that they used on the Wall Street movie, if you remember. And none of us could afford phones back then, so we thought that was the coolest thing ever. But if you saw it now, you think it's kind of silly. And then we had the flip phones, and those were really cool. And then we got these smaller phones, and then, wow, someone put a keyboard on a phone? That's really gnarly. It had the ability to type and see that. And then finally, we kind of get to our latest kind of lazier generation, maybe, who have the glass cell phones that we all like. And so, you know, you have to step back and say, well, what's the point? Why would anyone want to go put stuff in your shoe or on your shirt or whatever? It just doesn't make any sense, because we have these great cell phones to use, and so why would we do wearables? And so, I mean, to me, the answer is simple, is because cell phones have to go like this to read them, and if you have to type on them, they're so small you can barely see anything. And when you want to talk on them, you got to put them like this, and you have to go back and forth. So one of our predictions is this hunk of glass that you walk around with and you lose. If you're like me, you drop it in the toilet, you lose it, you crack it all the time. That's going to go away. And we believe that those features are going to disseminate to other parts of the body, other devices. And the reason they're going to do that is because things like passwords don't need to be typed. They can be learned from your body. And so we're going to talk a little bit about that today as we go through both the existing and the future of some of the wearables as we see it. So we're in presently what I would call the first generation of wearables. And, you know, to be frank, having seen the sensor technology out there that has shown so much promise for many, many years, it's not a very exciting first generation. The main things that we're seeing are watches and armbands, some heads-up displays and other types of devices. But because of some of the limitations in power and computing, you often have to have an external device to do a lot of the work. The form factors aren't where we want them to be, and where we're used to devices lasting weeks or months, some of them are lasting just hours. So we have kind of cut the cord with a sensor controller, but we have limitations on what we can put into these wearables. So a few examples that we have are patches, which can take some of our biometrics, heads-up displays, which are a great example, such as the glass shown, which really take advantage of the fact that the eye is eventually just seeing a little bit of light right at the back, and if we can manipulate that, we can make a lot of use of it. A little bit of flexible display technology, some nice clothing technologies like SIDS infant clothing, A few bands and watches that give us some entertainment value, some fashion value, and maybe some fitness value, and then some other devices. But the reality is that there's some big areas that can really benefit from these types of devices. And as the money from those areas does to wearables what it's done to other industries, we're going to see huge changes. So entertainment, communications, advertising, big data, productivity, point of purchase, health, fitness, navigation, access, and security. These are going to be the drivers. And that is going to require some technology improvements, but we're going to see that accelerating as we have in other industries. So we're going to talk a little bit about the technology. So why is wearables really happening? So wearables is happening because there's been a sensor revolution. Sensors used to be relatively large. We couldn't put them into the form factors you would wear. But a few years ago, we learned how to micro machine in silicon and other materials. And we can actually make gears and mechanics, strain gauges, accelerometers, even little gyroscopes in really, really tiny form factors. We can create Doppler signals. We can create contact sensors, both capacitive and direct sensors. And we can create fingerprint and other sensors that, for the first time, don't have to be cabled to some big assembly. And secondly, actually do a lot. And so wearables were a logical outcrop of the fact these sensors exist. And so what we saw for about a decade was a lot of very excited entrepreneurs running in with a wonderful sensor and then saying, well, we got this power supply and this interface element, and it was this big for a little sensor like this. And they go, well, we'll solve that problem later. But the reality is that problem wasn't so easily solved. So some of the sensors that you will be seeing, but that really haven't gotten out there because of the technology, one huge trend is morphing. So these are strained materials that can actually change their shape. So strained materials, if you put an electric field into them, literally can take on new form factors. So you can have a remote control where the buttons rise out of the device, keyboards that turn to keypads, but you can even have entire devices change their shape. We're seeing a little bit of this start with some products like the one on the top left, which is a keyboard with a membrane, and a microfluidic MEMS pumps liquid to kind of give you the feeling of texture on the keys. But there's a lot more exciting stuff happening where in an almost Star Trek-like way you see things rising out of the plastic. I'm actually surprised we haven't yet seen anyone introduce some nice wearables with that, but that's going to be pretty huge. The microfluidic pumps and similar MEMS are all going to, start to take over. And one of the interesting new developments is in the microneedles. Microneedles are an array of incredibly tiny needles that don't hurt. They just feel like sandpaper when you touch them to you, but they give us access to inside your body. So we'll have wearables that can touch inside. And that gives us some neat potential. You'll see some of the ideas we have there. So these are some of the interesting sensor trends. And then some of the other trends that are huge in the wearable space that we can make use of are the flexible displays, which are only beginning to be used, even though they've been around for a long time. One very interesting development we're excited about is at the center top. That's actually a liquid crystal thread. So you can actually sew a display. So we expect to see garments, handbags, other things where displays are sewn instead of glass, which really helps take the geek factor out of it. One of the greatest benefits, I'd say, that we can bring to having the wearable devices is the heads-up type displays. There's been a lot of interest in things like Google Glass and some of the contact lens products. These are great form factors in that you can just give displays that look like they're huge, like movie theaters, and you can do a lot with them. The problem with the displays is that it's really frustrating to lift your fingers up and click on little buttons or rotate your eyeballs in circles or do the things that you'd want to interact with them. So we're at this really interesting point where there's all this neat stuff possible, but with every new form factor, there's a piece missing. If you got a good display, you got a messed up interface, you got to get interface. Like the cell phone of today, you have to hold it separately and you can lose it. But those things are going to get improved. So we're going to see these sensors come along, but here's what it would look like to actually make use of some of these sensors today. So you'd have cool heads-up displays with all those sensors in them, and you'd have all these other things. But you'd have these huge circuit boards connected to them or things hanging on them. And that's why when you look at today's wearables, they only do one or two things. They don't do as many things as you think they could do, and they don't do all of the things that the sensors and other technologies would let them do. And so we're seeing some real limitations in size and form factor. Battery life is a huge problem. Screen and interface, we talked a little about that. If you have a good screen, it's hard to interface, whether it be on the cell phone or on the glass-type products. And one of the problems that may not have been as expected by the industry as it's turned out to be is that of motion and noise. We deal with many, many, many companies and help them create the watches and armbands and other products. And what happens is people create a product and they're elated when they get their heart rate or their heart waveform or their respiration or other physiological information into their band. And then they move. And when they move, the products lose their mind. And we've tested many, many, many of the products on the market, and they're just plain wrong when you move, when you jog, when you run. And it's pretty hard to actually get that information out during motion because, as you can see at the bottom, the waveform moves all around. And because the physiological signals are tens of microvolts to millivolts, we have to amplify them by thousands of times, which means the starting window is so small that if the signal moves, we lose it. So we either have to use a lot of computing power to zoom back out, find it, get in again, which takes time and power, or we have to wait. And so we get these incomplete waveforms that are hard to work with. And so this has been a big issue. At the same time, we have noise from radio stations, 60 hertz, your other muscles, which are much bigger in size. So we need selectivity in being able to look at those. And then just raw computing power. These are the hurdles that have to be overcome for wearables to really become what we hope they will. But that's starting to happen. So some of the major trends that are solving these problems are neural computing. So we and others are starting to mimic the brain when it comes to computing. The brain's an incredibly efficient calculator and a very power efficient one too. So with partners like ARM, we have created neural computing that can be 100 times less power than typical solutions that are out there and can be 100 times faster. And they contain algorithms that are new, and they're put in chips in new ways that do indicate that we will be able to get all the sensors that you saw and other ones into packages that are reasonable to wear and that people will appreciate. The other issue that's really slowing things down is what we call system rather than component thinking. So our industry is organized with the semiconductor people at the bottom or top, depending how you want to look at it, who make a chip, who then give it to systems level people who use the chip and put it on a green PC board, who give it to industrial designers and screen people who connect it to the form factor, who then give it to software guys who throw their stuff on the top. And that linear methodology is very efficient from a corporate perspective, but it doesn't work for neural computing because, not neural computing, but wearables and neural computing, because you need those people to work together. A good example is the only way to solve the motion artifact problem is to go right back at the beginning in the INA, crack the feedback loop, and have the software guy and system guy provide information and only feedback to that part of the system that it cares about so you don't saturate it regularly. And so generally the analog people, digital people, industrial design people come from totally different areas and don't like each other very much. And so getting those guys to cooperate is a big challenge. And so that's one of the hurdles that we have to get over. One of the other big solutions, though, is no power displays. So we've heard of e-ink and some of these types of displays. They continue to be restricted in terms of the color, the dynamic aspects of what they can do. But there are technologies like holosteric and other technologies that can do full color displays in a flexible form factor. You can roll them, you can bend them. When I look at the armbands out on the show floor, many of them don't have displays and some of them are just very basic, but the technology's out there. And the neat thing about the no power displays is you can write an image and they'll stay for years with no power. And you only have to update that part of the screen that actually has to update, like the last number in the minutes or something like that. So we don't have we don't have the power use. And then also improve batteries. We're seeing a lot of flexible batteries that last a lot longer. So we believe that with a different approach to working together with these displays, with the batteries, with this neural computing methodology, that all those sensors that you saw and more can come into form factors that'll be practical. So based on some of those technologies and what we're seeing and what we're being asked for, I put together some predictions of some of the trends that we're going to see and some of the products that we're going to see in the wearable space. And actually, before I go on, I'll say some of them are good and some of them aren't so good. So we'll talk first about the more stressful ones, and then we'll talk about the fun ones. So one of the ones that isn't so pleasant, we've been approached by a lot of people who basically want to see if their employees are working. And so we have the ability to build into devices like headsets and hearing devices and other devices, the ability to see your brain waves, the ability to see your muscles, the ability to see your movement. And the fact is, the motion and all of that information is a huge signature on whether you're working. So whether you're a call center or you're someone working on an assembly line or you're someone on a work site with a foreman's hat, we can track whether you're doing what they want you to do. And so, the funny video is kind of like an Office Space one where you have a siren on someone's head when they're not working. But more likely, the companies will collect data on their employees, and you'll start to see productivity scores which elevate certain people and take other people down. So it's kind of Big Brother. In the United States and other countries, that may not occur because of privacy laws, but in third world countries, just because of the productivity improvement, we think that'll happen. So the next thing is we're taking a lot of information that's really useful to marketers and to insurance companies and to governments, where we are, what our physiology is, defects in our health, all sorts of things that they want to use to market to us and to determine if we're a good risk and to determine our thought patterns in terms of how we'd vote and so forth. So that's going to be a negative. At the same time, that data can be used when you walk into a store to help you find the kind of things you're looking for. So there's some negative consequences to the wearables. And then there's some potentially promising ones. So with the health law changes, we're predicting that wearables will replace many of the tasks of your doctor. So what we're hearing about is doctors are getting less and less time to interact with their patients. They have to fill out paperwork. So we're seeing medical patches and interface machines that'll be used at the pharmacy and that'll be used even from home that'll monitor you. You'll download that information to your doctor, and he'll tell you to come in if you need to come in. The benefits here are more prevention. The disbenefits is the loss of that relationship. But we think that just the cost and other benefits of reacting to these kind of medical changes, this is going to happen. One of the more fun ones, we think electronic thread will help take the geek factor out of technology. So, my wife says she's never going to wear a garment or a handbag that has a screen on it because it's too geeky. So I said, well, I'm going to sew you a screen. Will you use it then? So we're going to see sewn screens with this thread, which is really neat, that just don't look like these shiny, kind of technology sci-fi movie things that we're used to. So that's kind of a neat one. So one of the most important innovations that are needed with the wearables is the interface. If we do put glasses on or we put something on our head, we don't want to lift our arms up. If we put it on any part of our body, we have to interact with it in a way that isn't like the cell phone typing on it. And so there's been a lot of development in those areas. We have customers that are using muscle movement, eye movement, all sorts of different gestures, like this to control volume or change a song, or this. All that can be seen through the EMG. So we're getting really interesting things. I mean, you can literally do kind of like you see on the sci-fi movies. We can detect that. These are good ways to interact because no one wants to lift their arms up to touch different things. One of the more interesting ones we call brain graffiti. And we call it brain graffiti because you can't think, okay, make the volume louder. You have to think of something angry and then something happy and then something sad, and then the volume would go up. So you have to train your brain. But we can actually see, based on you thinking of different things, very distinctive patterns that we can use to control. The gesture control, of course, is huge, and the fact that EMG is such a huge signal lets us use that. So teeth clicks, muscle ticks, eyeball movements, eyebrow movements, ear wiggles if you can do them. All these sorts of things will be used. And then we have some people that kind of want automated physiological reactions. So we had some people ask, can you have it, if you're sad, can you play sad music? And if you're happy, can you play happy music? And we said, can't you play happy music if you're sad, or go the other way? But another fellow wanted a band that would tell if you were aroused, and then email your wife to say you're thinking of her. But we thought that one could go either way. So this is we believe that you're gonna be seeing just getting away from this whole methodology we have now of just typing, and a lot more of these kind of gesture type controls that'll really help us bringing these sensors to life. All right, so this is one of the biggest areas. With the cell phones and so forth, the passwords and the access codes and so forth, they're very hard to remember. And therefore, we believe that they will be a thing of the past, because your body is actually a great physiological authenticity indicator. We can tell you're very unique. And so point of purchase, access control, remembering keyboards on your computer, this is all going to be done with the wearables. And last slide. Microneedles and microfluidic MEMS, we think, will bring new medical and entertainment offerings. So where you used to go to the bar and cry over your beer, we now think you'll go to the bar and cry over your martini patch, because you'll actually buy a MEMS and slap it on, one of these microneedles. And then a little bit more out there, but coming, are the living wearables. So some of my colleagues at the University of Toronto have invented cardiac string. So we can thread those between microneedles and actually create living pumps and living sensors just below your epidermis. None of them hurt. And so we believe that there will, in future, notwithstanding the ethics and other issues that'll come up, they're very, very efficient things. So we're going to have living wearables, and that's kind of way out there. So anyway, those are some of my predictions. The world is open for wearables. There's just exciting sensors that we haven't heard about, and we'll be amazed when we see them. We also see a lot on the show floor that's already very promising. And we look forward to seeing you all at future CESs to see what comes true. So thank you all. Appreciate it.